In making decisions with risks, under uncertainties, there's one tool that we can use. It is called decision tree. It is a method for evaluating risks using sequential decision making, in which a diagram points out graphically the order in which decisions must be made and compares the value of the various actions that can be undertaken. We will see an example of this. So it has decision points. You can use squares to denote it in the decision trees. We can have chance events designated with circles and are assigned with certain probabilities. So we convert all flows to present value, set up the branches of trees, move back from right to left or from bottom to up, computing the expected value of each branches, and eliminate branches corresponding to poor decisions, or which is not desirable decisions, and compare the net expected value of the final remaining alternatives to arrive at the solutions. Alright, let's look at the examples. Suppose the manager of a property cannot control weather, but knows that two different states might occur. It might be a very wet year or it might be dry years. Okay, so now this weather is a random event. The manager has two alternatives or two strategies, let's say. Either to plant rice on the land, which needs lots of water, lots of rains, or graze camels that does not like rain. The outcome of the manager's strategy will depend on the state of nature. If the manager plants rice and it turns out to be a very dry year, then the farm will suffer loss. But if it's wet years, huge profits can be made. In contrast, if the manager decides to graze camels and it turns out to be dry years, then there's a profit. However, if it's wet years, then the property is gonna make loss. Okay, so we can illustrate this decision making using decision trees. So here, the manager decides whether to plant rice or graze camels. Okay, if the manager decided to plant rice, then the weather turns out to be wet, then there's $4 million profit. If it turns out to be dry, there's $1 million or negative $1 million. If the manager decides to graze camels and it turns out to be wet, then there's $40 million lost. And turns out to be dry, then there's $10 million profit. Okay, so that's the decision tree. From this tree, we can calculate this. Suppose from the historical data, we can work out the probability of wet year. Okay, we can predict that there was a 20% chance of having wet year, so this is wet, and 80% chance of having a dry year. And let's look at grazing camel first. So this is grazing camel. So if it's wet, that's $40 million loss, dry $10 million profit. We calculate, we weight this two possible event by its probability. So it's 40 times negative 40 times 0.2, so 8, and 10 times that's 8. Let's calculate deviation of. Okay, let's sum them up. Sum them up. This weighted outcome. So mean is 0. -8 plus 8 is 0. Okay, so that's the expected profit when the manager decides to graze camel. Let's calculate the risks. So deviation from its mean, so it's -8. Sorry, not negative. So deviation from mean, so this, the first possible realization is -40 million from 0, so it's -40. And second one, 10 minus 0, so we get 10. Okay, square them, so $1,600 million square, and $100 million square weighted by its probability, so $320 million square, so this is $1 million square, okay, and $80 million square. Summing up, we got variance, which is $400 million square. And calculate standard deviation, square root it, we get $20 million. Okay, that's the mean expected profit and the risk standard deviation of grazing camel. Similarly, we can calculate for planting rice. Similarly, weighted each possible outcome, that's 0.8, -0.8, so the mean is 0. Expected profit of planting rice is also 0. Calculate the deviation for -1 square deviation, 16.1. So this $1 million square, $1 million square. Weighted, so is 3.2 and 0.8. Adding up, we get a variance, which is $4 million square. And calculate risk standard deviation, so $2 million. Right, so we now calculate the expected profit of planting rice and expected and the risk associated with planting rice. Then we can make a decision based on these two information. So we know that the expected profit of both strategies is 0, are the same. Okay. However, the risks are different. The risks are different. For grazing camel, the risk is $20 million. In contrast, for planting rice, the risk is $2 million. So now, which strategy should the manager, which decision should the manager make? That really largely depends on the manager's attitude to risks. Okay. So what is the manager's attitude towards the risks? Normally, attitudes towards risks can be categorized as 3 types. One is risk neutral. So the manager does not care about the risk. Okay, only care about expected values. Second is risk averse. The manager does not like risks. Okay, in order for the manager to take up risks, the manager needs to be compensated. Risk loving, that's in contrast, the manager likes the risks. Okay. So let's look at a side example, a separate example. Suppose that for every house, there's 1% chance of a fire occurring, and that if there's fire, it costs $100,000 to repair damage. Okay, given this, let's think, what is the minimum amount insurance companies could charge to insure people against the fire? So the expected payout, because we know that there's 1% chance of fire occurring. So the expected payoff is 100,000 times 1%. So that's $1,000. And this should be the minimum insurance premiums that the insurance company can charge. Okay, suppose that's the premium. Now the question is, would people be prepared to pay this $1,000 in order to insure their house against the fire? And again, the decision depends on the risk attitudes of the persons. Okay, if it is risk neutral, then the person will be indifferent between the risks and the purchasing the insurance, paying out $1,000. If it's risk loving, they will not pay this premium. If a person is risk averse, they will be prepared to pay more than 1,000, so they will purchase this insurance. So if a manager is also the owner of a firm, then attitudes towards risk is actually a personal affair, and many people are risk averse. So if the expected value of two projects are the same, the one with a lower risk, lower standard deviation will be accepted. In our grazing camel versus planting rice, in that cases, if the manager is risk averse, he will choose planting rice because the risk there is $2 million rather than grazing camel of $20 million. However, when managing a firm for a group of shareholders, so the manager is managing a firm on behalf of the shareholders, this may not be the correct thing to do. In particular, risk-averse behaviors by management necessarily implies that some potential profits will be foregone in an effort to avoid risks. Okay, some sort of opportunities are given up. But since it is possible for shareholders to cover themselves against the risks by diversifying their portfolios, so I'm the manager, I'm managing these firms, this business, on behalf of a group of shareholders who they themselves can diversify away the risks. So they might not want the manager to behave in a risk-averse manner. So in such cases, risk neutrality may be more preferred. So risk neutrality, if we assume that the manager should be risk neutral, that means decisions are made solely on the basis of expected returns, irrespective of the risks of the actions, of the decisions. So hence, a risk neutral manager will aim to maximize expected profit. Okay, expected profit. Thus, in the absence of certain information on revenues or costs, the aim will be set up, will be still follow MR equal to MC, but now MR is expected marginal revenue and MC is expected marginal cost. And for our example of grazing camel and planting rice, a risk-neutral managers will be indifferent. Either decision, either action will be fine.